Hello everyone, welcome or welcome back to my YouTube channel. So today is going to be a comprehensive guide of all that you need to get started with data structures and algorithm. So I was speaking with my younger brother who is studying computer science, and I was basically trying to encourage him to really practice his data structures and algorithm because now is the time. And I can say this because I also told a similar path, and I know it's way easier to study data structures and algorithm while it is your job to study it rather than coming out of school and then studying it out of a necessity to get a job. There is just like extra layer of pressure. So this is the and he told me, like most people, that he had not been studying it, although they were being taught in the school and it was being basically addressed. He had not been studying it because it was complex, and rightly so. Data structures and algorithm is not a walk in the park, but it is learnable. This is sort of a comprehensive guide if you are looking to start and are a bit confused on what to do and where to start. Also, I saw this really cool article that says that shows the importance of learning data structures and algorithm beyond the need for just a job search. Not all jobs actually require the knowledge of data structures and algorithms, so there's that to know. But knowing the inner workings of computer science gives you a more in-depth knowledge rather than just a platform or a tooling engineer. So I think the knowledge is actually rewarding in that you get better at problem solving. Either ways, if you are here, that means you know the value to you or you have a strong why. Anyways, let's get right into it. So I found this really great resource, roadmap.sh. I'm going to link it somewhere, but you can see it here. So it's a tool. They have basically a number of roadmaps and you can check it out yourself. Go to roadmaps, you can see a lot of things on computer science roadmap, programming language roadmap, front end, back end, DevOps, a number of it. I think the list is actually inexhaustible right now. They have so many and they are constantly improving. And I think this roadmap for data structures and algorithm is very comprehensive. So let's just go right into how this might help you. So when you want to start to study data structures and algorithm, the first thing you want to do is pick a language, which I assume most people watching this have picked. So here I picked JavaScript. You can pick whatever language you are comfortable with. You can pick C++, and then as you go on this journey you can also update the status. So what I did is I click on the language that I want to pick and I can just pick done or in progress or whatever is more comfortable for you. So if for instance you, like my brother, are just getting introduced to software engineering and you're just learning the language, you might want to put in progress or whatever you're comfortable with, and then you can see your progress being updated here in real time. So this basically, pick a language is the first path. We can see it starts from data structure, pick a language, and it branches out to all of these different parts. So you can choose one. You don't have to pick all the languages, just pick one, that's fine. And then when you pick a language, you start to learn the programming fundamentals. I mean, that's basic. If you were studying JavaScript, for instance, the language syntax are the basic things you need to know to actually work with the language. Functions, loops, variables, all of that good stuff. The control structures, if, while loop, for loops, you need to know those things. Then you also need to know the functions, the basics of OOP, pseudocode. Pseudocode is basically like writing algorithms but in English that you understand instead of writing to programming language. So basically, if you don't know any of these things, no problem. That is why you are on this journey. So you check them off as you go. As you go. So you learn language syntax. You feel slightly comfortable. And again, progress is better than perfection. You don't have to wait to learn all of the language syntax in JavaScript before you move on to the next. The beautiful thing about programming, that is a progressive knowledge. The more that you know, the more that it builds back on what you already know. So no knowledge is lost because the next step of progress you need needs the previous knowledge that you already have. So everything is a building block on each other. So don't worry, don't fret, you are in good hands. Now that you've picked the language, you've learnt the basic structures of a language, which is important. Now you can start data structures. You need to know what are data structures and importance of data structures. So at this point, I would advise that you pick a book. For me, I actually use this JavaScript data structure books, and I thought it was really good. It's a bit outdated though. They still use variables, some of these intricacies that are not being used in JavaScript anymore. Arrow functions is non-existent at this point. There is still the problem of global scope and local scope. So yeah, it's a bit outdated, but I really love the book because it was simple enough for me to start with. So when you pick a data structure, you learn what are the different kind of data structures. Primarily, we know arrays, we know linked lists. Knowing why does this exist? Why do we need maps? Why do sets exist? Knowing why these tools exist helps you to know when to use them. In fact, I think for me the most important thing was to know, okay, why does linked list exist? We already have arrays. Why are we using linked list anymore? So knowing the why behind this data structure, what problem they aim to solve, and then going in depth to know, okay, how to create a linked list, how to traverse a linked list, how to remove an item or a node from a linked list, how to add a node to a linked list. Like knowing those four basic operations of a data structure for me was really key, and I believe it's going to be that for you too. If you don't like read books, there are a number of articles if you prefer that. There are also great resources on YouTube. If you can also invest in courses, why not? But yeah, I'm just going to list some of these things you can see on the screen. Some will be in the chat box that you can just check. As you go through these data structures, it's important to just know why they exist. And also, we have this comprehensive list of basic data structures. So most of these are linear based. So we have arrays, linked lists, stacks, queues, hash tables. They are linear structure, linear structure, um, data structure. So here they follow the basic data structure rules. And also at this point, after you get a basic knowledge of what an array is, what is a linked list, and these things are no more far away concept, you might not completely understand these things, but you know what they are. You can to a large extent know the problem that they solve. Then you are able to maybe check them off, for instance. So you're like, okay, I click on array. I've done all of this good work. I've learned about data structures. So I click on array and I update the status. So I can just say this is in progress and that updates it. So I have a visual representation of everything I'm doing. I think it's so much fun to see that what you are doing kind of like there is progress really. So this helps. Also, you can move on to algorithm complexity. You see the arrow points down. This is just learning about time and space complexity. If we use an array, what is the time complexity? What is the space complexity? How do we calculate these complexities? And then you start to learn about the constant time, logarithmic time, linear time, factorial time, and all of these time complexities that are really important knowledge to know. Okay, why does this search take this long? Also, we have the notations, the big O notation, big theta, big alpha. I think this is actually big better. So you need to know the asymptotic notations. And after this knowledge is done, you can move on to sorting algorithms. There is the bubble sort, merge sort, insertion sort. Whew, all of these sorts that you need to know. Search algorithms, linear search, binary search, and we use most of these things in our daily operations. When you do Google search, how does it know what to bring up first? When you check for a name in your phone address book, all of these things we actually use them, but we do not know that we use them. So now we're taking it a step further from just coding a website and building React, building Vue, to actually understanding how these things work, which I believe is knowledge that truly sets you apart as a software engineer. Also, there is after you're done with the algorithm, sorting, search, there is also three data structures that you move on to next, and there are different kind of trees: binary tree, there is heaps, there are different kinds of trees, and there are also different algorithms to perform on those trees. How do you search through a tree? So a tree structure is kind of like different from an array in that data is not linear, so there has to be a different way to traverse through the tree data structure. And in this case, you start to learn about the algorithms for trees, and also while you are on tree data structure, you can also start to learn about graphical data structure. Graphs are different from trees, but they are also non-linear data structure, and it gets easier the more you start to study it. So all in all, this provides a good way to really understand some of these problems. And so when you get to advanced data structure, complex data structure, you can see all um, those paths as you kind of go along. There's also problem solving techniques that make it easier. For example, brute force is just getting a problem, solving it straight up. You write the pseudocode, you solve it, the first thing that comes to mind, which is fine. But then you start to learn about how do we make it efficient. We talked about the time and space complexity. So problem solving technique is okay, how do we make this efficient? And there are a number of ways, number of techniques that already exist that you can use. And also we have the platforms for practice, there's lead code and all. So as you start to learn this thing, you don't have to wait till you get here platforms of for practice to start actually practicing. You can start practicing when you learn time versus space complexity. You can check the nets for simple problems to start to solve. You learn about arrays. You can search for some problems on lead code that concerns arrays and all of those things. We already have a number of playlists that will help you data structures and algorithm on this channel. There is the coding challenge, there's data structures and algorithm, there is Sean Prasad patterns. There are so many good lists, but this is also one that is much more structured that we might incorporate under the technical coding challenge. So as we make progress, we just keep on adding that to the series, and this is going to be the first of a series of problem in that challenge actually. And also yeah, keep on practicing. And the most important thing is to actually not give up, because you can get tired, that is possible. But the most important thing is to not give up. Also, I really wanted to share this really cool resource with you. um if you're familiar with Neat Code here on YouTube, so he also has this really great roadmap that shows a sort of mental visualization or mental mapping how to solve lead code problems. So if you think back to the analogy that I said about how programming knowledge kind of builds up on one another. If you learn about arrays, you can kind of use that knowledge in loops and all of those things. So the knowledge builds off of one another, such that nothing is actually really missing. So if you want to actually build and exercise that memory muscle, this is a good way to start. So, or this is a good place to start, especially if you already have some knowledge of data structures and algorithm. You already know about arrays, linked lists, queues. You can design a queue by yourself. You can traverse through a queue, but now you want to practice more lead code problem. This is a really good roadmap, because now you start from the array and hashing, then you move on to two pointers, which builds off the knowledge of array and hashing. Then stack, which also builds off the knowledge of array and hashing. Then you move on to binary search, which builds off the knowledge of two pointers and arrays and hashing. So no knowledge is really lost in that. The next problem that you solve build off a knowledge you already use. So when you get to trees, because you've already solved binary search and you solved linked list, you are able to better understand how to solve trees rather than jumping straight to trees without doing sliding window and two pointers. So all of those knowledge builds off of one another. So if you already have some practicing knowledge, some data structures and algorithm knowledge, this is also a very good place to start. And there is one more thing. But if you also want to go in depth with computer science, there's also this good roadmap that you can check out. So some of the data structures and algorithm topics were much more focused on, oh, you're preparing for maybe a coding interview. These are some of the topics that are highly required. But there are also some knowledge that is taught in computer science in depth that you might benefit from. And maybe you don't want to start with this right now. Maybe you are done with all of the knowledge learning on data structures and algorithm. Maybe you've learned about graphs. So now you want to start looking at adjacency matrix and adjacency list. So this is an extra step to go if you are interested in that sort of thing, or if you feel like you want to brush up on your computer science knowledge. There are very number of knowledge to learn. And the thing is, if you already have data structures and algorithm, it is way easier to start to want to look into caches, LRU cache, and sub and brute force search, and not more sparse substring search, and all of those good stuff. Design patterns, basic math skills, combinatorics and probability. So yeah, I just thought to share this with you. If you are looking to study data structures and algorithm and you don't really know how to or where to start, or it's getting daunting, I really hope this helps, and I hope that you are accountable to your goals. Thank you so much for watching this video. I'll see you in the next one. Bye.